Okay, so we're going to be working with some parabola problems here, showing you how to do the interactive part of Khan Academy. It says a graph, you need to graph a parabola whose vertex is at 3, 5 with a y-intercept and y equals 1. Okay? So we got to have a vertex where? At 3 and a 5. Okay, so right here, this is at 3 and 5. But what do we need to have a y-intercept? We need a y-intercept at a 1. So I'm going to put this one here. I got to do a little manipulation here. Oh, there we go. Maybe I can move this over. So I have to do just a little bit of manipulating with your, with your mouse. Okay. Well, you watch. If you move the dot up, it'll go open up. If you move this dot down, it'll go down. So you do a little bit of manipulating. So we have a y-intercept at y equals 1, which is right here. And we have a vertex at 3, 5. So what would this vertex be known as? What's another word for this vertex? It's the highest point known as the maximum. Right? It's the maximum height. Okay. If it was like this, it would be known as the minimum height. Okay? And that's what you're doing. All right. So right here it says a parabola intersects the x-axis at 3 and 9. What is the x-coordinate of the parabola's vertex? Okay. So we kind of did this one on the board. Right? Let's do it real quick. We have a y-axis. We have an x-axis right here. It says the x-coordinate of the parabola's vertex. All right. So I'm going to put. We have a root at 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Now, whether the parabola opens up or whether it opens down, it doesn't really matter for this problem. Okay, so I'm just going to draw a parabola that opens up. Okay. Now, something we talked about yesterday. There's this line called the axis of symmetry. What does the axis of symmetry always do? It passes straight through the vertex. Now, I'm not drawing this very well to scale. Bless you. All right? Well, what I need you to understand is this right here, this gap on either side of these two roots is going to be the same. Okay? So if this right here is at a 3, and this right here is at a 9, your x-coordinate, for whatever this vertex is going to be at a 6. So I don't know what the y-coordinate is, but the x-coordinate right there, that's what it passes through, is right at a 6. So it's always halfway in between. So what's the math behind it? You take 3, you add 9. By the way, this is what you can do with all the roots. Yeah, that's 12. And 12 divided by 2 is 6. So you can always do that for this problem. All right? We have the same problem we did up here on the board. So what can you do with these? Take those, add them together, and then divide them by, add them together, divide by 2. Okay? So this answer is 6. So I got to go over here and type it in. Okay. Right here it says graph a parabola whose x-intercepts are at x equals -3 and 5, and whose minimum value is y equals -4. So I have a y value that's -4. All right, but I have an x value that needs to be at a -3 and a 5. So I gotta move this around. Oh, I think that works. So take a look at this. I have a root right here. That's at -3. I have a root right here, a solution, or 0 at 5. And I also have a minimum value right here at a -4. So it meets all the conditions. So that's what you guys are doing when you guys are working these problems. Okay. Now, what we're going to do next is we're going to go to what's called the zero product property. Okay, we're going to take a look at this. Okay. And what I want you guys to do, all right, is I want you guys to we're going to do this by hand, and we're going to use Desmos. Okay, so if you guys put this in your journal real quick. All right, so I'm going to rewrite this a little bit bigger. We have 2x minus 1, and we have x plus 4 sets equal to 0. It says write the smaller solution first and the larger solution second. Okay. Now a solution is wherever the parabola touches the x-axis. solution. So think of it. Whenever the parabola crosses the x-axis, that's known as a solution. So this has two solutions. And all you have to do is you really wouldn't have to use Desmos, okay? But right now, all you have to do is think about what number could I plug in there when I add it to 4 that makes it equal to 0? Negative 4. So right now, that's one of our solutions. Negative 4 plus 4. What does that mean? Why do they call it the zero product property? Because any number times 0 is 0. So if I plug in this 0, everything zeroes out. So this is the one that makes it a little bit trickier, is we got to figure out what number here would you have to plug in minus a 1 to make it equal to 0. Okay? 2 times what number? By the way, what number minus 1 is 0? What number minus 1? 1, right? So somehow we got to get this 2 into a 1. What can we multiply 2 by to get it to a 1? 2 times what number gets it to 1? It's like 1 is something of 2. 1 is, no. You gotta it's almost like you gotta split 2 in half. If you plug in a half, 2 times a half is 1. 1 minus 1 is 0. So what's my other solution? A half. Now, let's say you're like, Mr. Mood, I am not going to get that just by doing stuff in my head. So what could you do? Here's what you do. Check it out. All you have to do is take it and do 2x minus 1 and set it equal to 0. Then what can you do? Add 1 to both sides. Do a little problem solving. You get 2x equals 1. And what's the last step when you're solving for x? Divide both sides by the number in front of it, which is 2. So that cancels out, and what are you left with? A half. So let me explain to you how you could use it, how you could use Desmos to help you. Okay? So let's go to Desmos. Alright? Go to Desmos. Now I'm going to do right here, I'm just going to type it in exactly as it appears. Alright? I'm going to put parentheses 2x minus 1, close parentheses, open parentheses, x plus 4. Close parentheses. Okay? Now, automatically, what pops up on the graph for Desmos? Look here. Negative 4, 0, and 0.5. And 0.5 is a half. Right? Now, what else does it give us? It gives us our y. So it gives us 3 points automatically. All we need is this 0 and this 0. Okay? So what do we have to do here? I have to type in a negative 4, and I got to type in a 0.5. So we go over here. I'm going to type in a negative 4 because negative 4 is smaller. It's smaller than a half. Now you could type in a half or you could type in 0.5. I like fractions. Okay? So I'll do one more. Okay? We'll do one more. So I'm going to do this one by hand and we're going to do it by Desmos. So negative x minus 2 and negative 2x minus 3. Okay? So I'm going to do this by hand to show you once again. We're going to set this part equal to 0. Okay? And then I'm going to do this one right here. I'm going to set this part equal to 0. So I'm going to set right over here, negative x minus 2 equals 0. And over here I'm going to do negative 2x minus 3 equals 0. Okay? On this one, if we want to do it, I'm just going to add x to both sides. Okay? And we get negative 2 equals x. Now what does that mean? That means we have one of ours. X equals negative 2. On this one, what I'm going to do is I'm going to add 2x to both sides. That zeroes out. We get negative 3 equals 2x. And I have to divide both sides by 2. Those 2's cancel out. And we get x equals negative 3 over 2. Now, this one's kind of tricky. We got which one's the smaller one? Okay? Negative 3. No. Negative 2 is smaller than negative 3 over 2. Negative 3 over 2 is negative 1.5. Negative 2 is smaller on the number line. Okay? Now how can you check this on Desmos? Watch. all you really have to do is look at the graph from left to right. Like what? What do you mean look at the graph? Like, zoom in, zoom in. Read it from left to right. Which is smaller? -2, then it's negative. So how do you interpret it? Which is the smallest? Read it from what? Left to right, just like you would on a number line. So I'm going to type in -2 and -1.5. And those are my two zeros, or my two answers, or my two solutions. The smaller one is -2. The larger one is -1.5. Or, see where it says your answer should be a simplified fraction? Okay, so you know what? We'll do a simplified fraction, which is what? -3 divided by 2. And that's it. That's what you guys are doing. Alright, now some of you guys have been asking me about function notation. So y equals, they could also say, if they wanted to, they could say g of x equals, and it would be the same function. Alright, this is called function notation. That's what it's called. Alright? So this right here, if I change it to g of x, I could change it to, most of the times you see it, function notation, you see f of x. Okay, that's what you typically see. But if I wanted to, I could change it to h of x. I'm just going to change it to h of x and just leave it. This is called function notation. Okay. Now, let's just kind of use our brains real quick. All right? What number could I plug in there to make this side, all of my y values, because h of x means what? It means y, equal a 0. What number could I plug in to make everything equal to 0? What number minus 5 is 0? Yeah, 5. That's one of my roots or my solutions. Okay? What number could I plug in right here to make this particular expression equal to 0? -1. Now, what did we say about the vertex? The x value for the vertex is always perfectly in between those two numbers. So watch what I'm going to do. Take -1. I'm going to add 5. And I'm going to, how do I find the halfway point between them? Add them together and divide it by 2. -1 plus 5 is 4. 4 divided by 2 is 2. So automatically, what do I know about the vertex? I know the x value is a 2. Alright. But it says, what is the vertex? What do we also need to find? We need to find the y value. Alright, so what I'm going to do right here, alright, we have y equals, open parentheses, x minus 5, x plus 1. Now, what did we find our x value for our vertex to be? We found it to be a 2. So I'm going to take a 2, and I'm going to plug it in right there. I'm going to take a 2, and we're going to plug it in right there. So here we go. Watch me plug in a 2, all right? I have 2 minus 5, and I have 2 plus 1.
-3.
You're right, -3 and 3. So what is -3 times 3? That lets me know what my y value is equal. So once I found my x value, what do I need to do? Plug my x value back in, and what does that give me? My y value. So my vertex is at 2 and at -9. And that's how you do it by hand. Okay? Alright. Here's how you do it by Desmos. You said y equals, alright, go over here, x minus 5, x plus 1, so I'm going to go over here and do x minus 5, okay. Over here I'm going to type in x plus 1. I have to zoom out.
It was x minus 5, x minus 1.
Oh, is it x minus 1? No, it wasn't.
It was?
It was x plus 1. See? X plus 1. So, -1 and 5 were my roots. See, look. -1 and 5 are my solutions. Hey, look. There's my vertex. So, by the way, what does Desmos always give you with a parabola? Watch. We're going to click all the points that it gives, and we're going to highlight it, and I'm going to take a picture. I want you guys to understand what Desmos gives you. it gives you a root or a solution. It gives you the other root. What's this point right here called? That's the Y-intercept, so it gives us the Y-intercept. And what else? What other point does it give us right down here? It gives us the vertex. And what did we say? By hand, our answer was 2 and a negative 9. But that's how you do it by hand. Okay? Yep. Think of it this way. You only have 3 questions. This one's a little trickier. It says what? What is the vertex of the parabola? And then what do you have to do? Graph it. Now, the cool thing is we can actually graph a couple of points, and then it helps us find our vertex. So what are the roots that we would have to graph? Like, what number am I going to have to plug in here and plug in there? A 2 and so right here, I got to put a 6 here, and I got to put the other point right there. So that's what I'm going to have to do. Okay. So this will be the last one that I do. All right. So I got to figure out. I got to get to the 2. I'm done. Hold on. This is the last one I'm doing. Oh, boom. Does that hit a 2 and does that hit a 6? It hits the 2. It hits the 6. So what is it asking for? It's asking for what is the vertex. That's the vertex right there. What's that ordered pair for the vertex? Would you guys interpret that order?
4 negative 4.
Oh, sorry.
4 negative 6.
Yes, 4 negative 6.
I got 4 negative 4.
I got 4 negative 4.
Okay, well let's just check. Right? Okay, so we could, you know what? Yeah, so guess what? It is 4. Listen, you guys got the vertex, the roots stay the same. The vertex, it can be wider or more narrow. So yeah, so it is definitely 4, negative 4. Okay? Alright, now, what can we do to make sure we got it right? Well, take a root, we add the other root, we divide it by 2, we get what? 12. 8 over 2. 8 over 2 is 4. So what do I have to plug in right here? I have to plug in a 4, and right here I have to plug in 4. 4 minus 2 is 2. 4 minus 6 is negative 2. 2 times negative 2 is negative 4. So it's going to be 4 and a negative 4. Okay. This one's just asking you to graph it. So you all you have to do is graph it correctly. Make sure all the points, make sure the vertex and the roots all match when you graph it.